Today we are going to work on special right triangles. Okay, there are two special right triangles. The first one is an isosceles right triangle. Raise your hand. What does isosceles mean? Tyler?
Two sides are true.
Okay, what else is true about an isosceles triangle besides two sides being congruent?
Two
Go, Drew.
angles are congruent.
Two angles are congruent. So if we have a right triangle that is isosceles, then its two angles that are left are 45 degrees. Don't know how that, okay. This is what I call a 45, 45, 90 triangle, or a 45, 45 right triangle. And because of what happens with the Pythagorean theorem, because of what happens with the trigonometry that we're going to learn after spring break, we already knew that our sides are going to be congruent if it's isosceles. But what is special about a 45, 45, 90 triangle is that the hypotenuse is radical 2 times whatever the leg is. Okay, I want you to go ahead and draw this arrow with the times radical 2. And every 45, 45, 90 triangle, whatever the legs are going to be the same. Notice how they're labeled as X. And the hypotenuse is always going to be the leg, no, not double, radical 2 times as much. So not times 2, times radical 2.
So what does that mean?
Okay. So what does that mean? So this relationship happens every time. So if I have a right triangle, whose angles are 45, 45, and then 90. If my legs are both length 3, then to get to our hypotenuse, we are going to multiply our leg by radical 2. So our hypotenuse would be 3 radical 2. Now, you can do the Pythagorean theorem every time to figure this out, but if it's a 45, 45, 90 triangle, it's going to be this relationship every time. So we can just save time. If it's a 45, 45, 90, this is going to happen, and we can just get our answer in 5 seconds instead of 30 seconds. Okay?
So it's like there's a 1 or like the like before the radical.
Yeah. Tyler?
So do you do the high or the what's called the
Pythagorean theorem. But this is a shortcut.
I don't know, but if you do a squared plus b squared equals c squared, is that just doubling the legs to get c squared?
So no, because you'd have 9 plus 9.
Yeah, but they're the same thing.
18. And 18 is 9 times 2. So Tyler, a squared plus b squared equals c squared, right? So we have 3 squared plus 3 squared.
Yeah.
Well, 9 plus 9 is 18. So we get the square root of 18, which is 3 radical 2.
Oh, it's because you then got to
Oh, so it's okay.
9.
Yeah, it's always going to be simplified. Okay. All right. So let's draw another one. Okay. If we have this, where is there a negative?
could just be like that. Well, yeah. those look like down on the theorem 9 point.
Oh, like, you know how like, it's like a hyphen,
It's just look at that.
like, you know,
It's just showing like separate.
because they're like connected. Instead of a comma, it's just a dash.
Oh,
Okay, so this is a triangle right here. Now, if that is a right angle, then we know if it's isosceles, then our angles are 45. What is this side over here? That one's also 5. The legs are the same. Dalton, do you have a question and I forget to come back to you? No? Okay. And then we're going to multiply our leg by radical 2.
Why have you not been doing this the whole time?
This is a special case. Okay, now what happens? What happens when we know the hypotenuse? How would we get to the legs? Well, okay, so if from leg to hypotenuse, we multiply by radical 2, then to get from hypotenuse to leg, we would need to divide by radical 2. Okay, now let's do that. It's amazing. We already talked about how to divide by radicals. 6 divided by radical 2. Hold on. So some of your brains are working so fast and I love it, but let's wait for the rest of the class. If we're dividing by radical 2, can we leave radical 2 in the denominator? So you're right, Emily, we need to multiply by radical 2 over radical 2. So we have 6 radical 2 over 2. So our answer is 3 radical 2. Dalton, are you okay?
Yeah.
Are you okay? Okay. What? Why are we times it by 2? Times radical 2. So now we can check ourselves, right? 3 radical 2 times radical 2, would that get us back to 6?
Yes.
Yes, it would. Okay, 45, 45, 90 triangles, that's where it's at, okay? Now, our 30, 60, 90 is a little bit more complicated. Here is our 30, 60, okay? We have 3 sides. We're going to call them the short leg, the long leg, and the hypotenuse. Now, what do you notice besides one being shorter than the other? Short leg and long leg. I want you to notice that. Do you remember how we talked about how like the biggest angles across from the biggest side, right? I already said besides that, but thank you, Colton. The long leg is across from 60. The short leg is across from 30. Are you with me? Okay, now here are our relationships. You always need the short leg. So if you don't have the short leg, you have to find it first because these all stem from the short leg. The hypotenuse is double the short leg. Dalton.
No, because.
Yes, that's why I just wrote Dalton.
Oh.
If you have the short leg, you are gonna times 2 to get to the hypotenuse. He was staring at me, he was listening, it just didn't. Yeah.
Could you repeat that?
Okay. Okay, can we just look right here? Everyone look right here. He is, don't worry about
Happy
him.
birthday, Cole.
What about yourself?
Happy birthday, happy birthday.
Hold on, at the end. Happy birthday to you. Okay. Are you 17? Okay. Okay. All right. Okay, can we focus now that we've sang happy birthday? Okay, from the short leg to the hypotenuse, we are going to multiply by 2. From the short leg to the long leg, we're going to multiply by radical 3. Long leg to the long leg. Okay, hold on. Just hold on. Jonah.
So is radical, what's bigger? X is the radical of 3 or 2x?
The hypotenuse is always bigger. 2 is bigger than radical 3, Jonah. Because radical 4 is 2. So 2 is bigger.
Do you know it's Harper's birthday?
It's not.
What'd you say?
No, it's not. Stop now. Ben, what's your question?
Wait, so what happens if it's not radical 3? Then would you, like if it's radical 4, would you multiply by radical 4?
If it is a 30, 60, 90, your relationships are times 2 and times radical 3 and nothing else.
Wait. Okay, so it's not radical 3 just because there's a radical.
It's radical 3 because we have a 30, 60, 90 triangle.
Okay, not
Okay.
because it's down.
So these are basically our special triangles that we have shortcuts for. So draw this triangle with me. We're going to be doing 3 of them, so make sure you have space. Okay. We have a 30, 60, 90 triangle where I am telling you that this side is 2.
What? It's Jack.
Okay, 2 is the measure of what?
Short leg.
Because the angle is
Not on the scale.
It is not drawn to scale. It's a pretty terrible drawing. But it's across from 30, so it's a short leg. Across from 60 is the long leg, and across from the 90-degree angle is the hypotenuse. So we know that if we have the short leg, then we can multiply by 2 to get to the hypotenuse. And we can multiply by radical 3 to get to the long leg. Good job.
Let's just stop and take a look at everything we've done. Like, I disagree. Let's not. You should text it.
We will on Thursday,
Today is Thursday.
a week from tomorrow. Okay, so now write this one down. Adri, does this look a little bit better? It's mid. Okay, that's fine. I can deal with that. All right, draw this triangle, please. In the same place. Where I told you we're doing 3 examples. Okay. What did I give you the measure of? The hypotenuse. Across from 30 is the short leg, and across from 60 is the long leg. Hold on, hold on, hold on.
From the short leg to the long leg, that's radical.
Okay, so we know, I'm gonna come back to here. From the short leg, we double to get to the hypotenuse. We multiply by radical 3 to get to the long leg. Now, if we have the hypotenuse, how do we go this way? We have to divide by 2. So we're gonna divide by 2. Okay, once we have the short leg, now we can get to the long leg. Okay.
Why'd you write -3?
That's a multiply. Okay, one more. What do you think I'm gonna give you in this example? All right, here it is. Sorry, my iPad blew on battery for some reason. Okay. So let's go ahead and just label these real quick. This is the long leg, this is the short leg, and this is the hypotenuse. If you do not have the short leg, you have to get there first.
It's super easy. You do 4 over radical.
So we need to divide by radical 3. So if I take 4 divided by radical 3, you are right, we're gonna have to rationalize. So yeah, 4 radical 3 over 3 is our answer.
Wait, but then, oh, yeah.
Okay, but then Carson, how do we get to the hypotenuse? So to get to the hypotenuse, we're gonna double that. You're gonna multiply by 2.
We only double the number that's outside.
Because it's 2 over, yeah, it's 2 over, it's 2 over 1.
5 with the 1. Oh, because you don't.
Wait, why didn't
So this is like 2 over 1.
Oh, yeah. I always do it.
So like, on this one, I was talking about.
Yeah. Okay, so I'm gonna give you a little test here. You all are saying this is so easy.
I don't think I said that.
I never said that.
I did not say that.
I did not.
I said I mixed up things. Okay, I did not say that because it's not clicking. Wait, this is what?
Oh, I All right, so eyes up here. Does everybody have one? I feel like I should only have one.
Are we gonna get graded on this? How many people are gone?
Just one.
Is this graded?
I saw Layla
Oh,
this
good
morning.
gracious.
Yeah.
All I want you to do, this is like part of our
I saw
notes.
Layla in class.
Oh.
I need you to complete, don't worry about the little, just fill out 1 through 9, X's and Y's.
We don't do the notes.
This is part of your notes.
What'd you get for the first one?
I don't know what to do.
X is 8, right? I already forgot. Oh.
Y is 25. X is 50. Wait, what do you get for the one? Did you get X is 8, Y is 2, 32. I got 45, 45, 90. It is. So you already know X is 8. And then 62.
What do you remember 1,000?
8 and then 8.